All right, here we go. This is Pre-Calc 11, solving radical equations. So a radical equation has a variable under the radical symbol. So here's three examples. If you look at those, this one here has the variable x underneath the radical symbol, in this case the square root. This one also is a radical equation because there's a variable underneath the radical. I can even make that a cube root if I wanted to. That would still be a radical equation, even though there's a variable not underneath the radical symbol. As soon as there is one underneath, it's considered a radical equation. This one here has a radical in it, but the variable is not underneath the radical symbol, so this is technically not a radical equation. Still an equation, just not radical. Alright, so the goal today is to learn how to solve these. So hopefully you can see this. I've got the steps here that we'll go through. I've got them already pre-written out, so you don't have to sit there and watch me write that out with my chicken scratch writing. So here is an example of a radical equation, because it's an equation, it has an equal sign, and it has the variable underneath the radical symbol, and our whole goal is to find out the value of x such that when you place it into here, when you take your value and add 2 to it and square root it and add 5, you would get 11. Now you might even be able to look at this and just know it by instinct. You might instinctively know that this has to be a value of 6 because 6 plus 5 is 11, and what number square rooted would give you 6 would be 36. And so what would x have to be to make this 36? So you might even know instinctively that this is 34. But we're going to show you how to solve it when things are not obvious or if you don't have that instinct. Okay, first step is to isolate the radical, which means you look for the radical symbol and you want to get this guy by itself. So our goal right now is to isolate the radical. So what we're going to do that is we're going to do the opposite of add 5. We're going to subtract 5 from both sides, and you end up with the square root of x plus 2 equals 11 minus 5 is 6. And at that point you've isolated the radical, which makes this a little bit easier to work with. And at that point what you're going to do is to take away the square root. You are going to square both sides. Now make sure you square both sides to keep the equation balanced. So I'm going to rewrite it here just for your viewing pleasure. I'm going to square this side, and I'm going to square the other side to keep it balanced. So when you square root something and then square it, you just end up with what's underneath the radical symbol, which is the radicand, in this case x plus 2. 6 squared is 6 times 6, which is 36. And then at that point, our first step was isolation, second step was square both sides. Now we're going to solve the new equation. And look at that equation, that new equation, that's just a grade 9 special right there. That's just a linear equation. You can solve that easily for x by just subtracting 2 from both sides, and you get 34, which we kind of knew from the beginning. Now the last step, which is probably the most important, and most people skip over this because they think that it is a kind of a foolish step because they think they've already solved it. Sometimes in radical equations, you can get answers out that work out algebraically, but actually don't work. So this is a really important step. You need to check it. So to check it, you write out the equation, the original equation, right here. I'm not doing anything fancy, I'm just recopying the original question. And then I'm actually going to physically replace the variable x with 34, our answer. And we're just going to show that the left side does in fact equal the right side. And like I said, sometimes this can actually give you a false answer, and then you have to go back and throw that answer away. So this is the square root of 36 plus 5. Square root of 36 is 6. Is 6 plus 5 11? 11 equals 11. So it checks out. And because it checks out, this is the actual answer. So the solution to that question is x equals 34. Okay? If it didn't work out, we'll talk about that in the next example. You would call that an extraneous root. And the definition of an extraneous root is an answer that doesn't algebraically works, but it doesn't work when it checks out and you actually throw it away. It's kind of like a reject. Another word for extraneous would be reject. Okay, next example. Okay, so the second example is this radical equation, which is another equation which has a variable underneath the radical symbol, so it is a radical equation. So as soon as I see that, I know that I'm going to be following those same steps for radical equation solving. So the first thing is I'm going to isolate the radical. Now, because there's a negative out front of this radical here, I'm going to do two things. I'm going to move this by adding that entire beast, so to speak, to both sides. So I end up with this. Now I haven't isolated the radical yet, but I've got the radical in a better state because of the coefficient out front here is just an imaginary +1, not a -1. And then I have one more move of subtracting 6 to the other side. So there's my first step. I have isolated the radical. Now I'll square both sides. Now this side is a binomial and I have to square it. This side, when I square a square root, that's a really nice, beautiful side. That just gives me the radicand, which is 2x plus 3. So this side is nice. This side is a little bit unfortunate because I have to write this out twice. There's no other way out. I can't shortcut it, and I'm going to have to FOIL this. So I distribute this out. X squared minus 6x, which is minus 12, plus 36 equals 2x plus 3. And at that point, I have squared both sides, and now I'm left with solving the new equation. And what is the new equation? It's got an x squared. It is quadratic. And how do we always solve quadratics? Is we always get them equal to 0. So I'm going to subtract 2x from both sides and subtract 3. And you end up with x squared minus 14x plus 33 equals 0. And how do I solve a quadratic equation once I've got to that point? I would do it one of two ways personally. I would solve it by factoring if I can, and then if that doesn't work, quadratic formula with my ABC quadratic formula. In this case, it does factor, so I'll take advantage of that. And I get 3 and 11, negative for both, double check, x squared minus 11x minus 3x is my negative 14x plus 33. Out drops 2 possible solutions, and this is again the most important step for radicals is I have to do a check step. And unfortunately there's 2 answers, so I'm going to take the original equation back here. I'm going to write it out twice because I have to do this twice. The more answers you get, the more checking you got to do. And then I'm going to check to see when I plug 3 in for x. So when you substitute, always use brackets, and then just be really vigilant at this point. So I get 3 minus the square root of 6 plus 3, which is 9, which is 6, and end up with 3 minus 3. Is that 6? No, because 3 minus 3 is 0. Is 0 equal to 6? That's a big no. So that tells me to go back here and cross off that answer, and that is an extraneous, looks like extraneous, but extraneous root, meaning it's a reject answer. And then I'm going to plug 11 into this one. So 11 minus the square root of 2 times 11 plus 3 all square rooted equals 6. Does this work? 22 plus 3 is 25. Square root of 25 is 5. Is 11 minus 5 6? Yes, 6 is equal to 6. So 11 is an answer. So the only solution to this, even though 2 came out of the woodwork, the only answer that works is 11. Hopefully that makes sense. So, recapping, radical equations, variables underneath the radical symbol. As soon as you see that, you're going to follow these 4 steps, and it's just like following a recipe for baking cookies. Just follow it to a T. you can go wrong in a sense of making goofy algebra mistakes, but as far as process, that's the only way you can solve these without making like fundamental errors. Those are the practice questions that go with this unit from our textbook. And the textbook, remember, is this guy here. And those are the page numbers. We'll stop her there.